All right, so we embedded our 45-degree special triangle to help us find this point, square root of 2 over 2 for both x and y. And now what we can do is reflect that triangle across the y-axis to help us find another point on our unit circle. Right, and this reflection is the same type of reflection across the y-axis you've seen before when you talked about transformations of functions in pre-calculus. And so when we flip a point over the y-axis, the only thing that's going to change is, well, and we can see this visually, the height of the point is going to remain the same, right? Both those y values are going to be the square root of 2 over 2. It's the x coordinates that really get affected here, right? Instead of getting to our point here by traveling to the right, square root of 2 over 2 units, we now have to get to this corresponding point over here by traveling to the left, the square root of 2 over 2 units. And so that means we're traveling left, x has to be negative. So our point is going to be negative root 2 over 2 and positive root 2 over 2 for this point on our unit circle. All right, so we now know this point is on our unit circle, negative square root of 2 over 2 and square root of 2 over 2 for x and y. But we now need to figure out what are the angles or arc lengths that get us to this point on our unit circle. Well, there's a couple ways to figure this out. Remember when we were using our little reference triangle to help us find this point? Our first reference triangle was set up in the first quadrant, and we had to reflect that across the y-axis to move it into the second quadrant here. And so this is where our reference triangle or reference angle would be. And this angle right here would be our 45-degree angle. So we know halfway around a rotation is 180 degrees. We then have to go backwards our reference angle of 45 degrees. So that's going to be 180 degrees minus 45 degrees for 135 degrees. Right, that is the angle that corresponds to this terminal point or end point on our unit circle. The angle of 135 degrees will get us to the point negative root 2 over 2 for x and positive root 2 over 2 for y. But we also want to describe that arc length or angle in radians, and that'll be 3 pi over 4. A couple different ways we can kind of figure that out. One is, well, we know that this arc length, getting us halfway through our circle in the first quadrant, was pi over 4 radians. To get through the second half of our first quadrant, we have to add that arc length to itself. Pi over 4 plus pi over 4 gets us to pi over 2. And doing one more distance of pi over 4 will get us to that point we're now interested in at 3 pi over 4 for the arc length or angle in radians, or corresponding to the angle of 135 in degrees. Right, and you can bet that we're going to do the exact same thing for our other two known points. Right, so if we reflect our point 1/2 comma square root of 3 over 2 across the y-axis, only the x coordinate changes and it becomes negative. So we find a corresponding point to be negative 1/2 positive square root of 3 over 2. And we can also reflect that point corresponding to 30 degrees or pi over 6 across the y-axis. And that'll give us our point negative root 3 over 2 for x and positive 1/2 for y. All right, so our next task is, what are the angles or arc lengths that are associated with or correspond to these two new points? So we can use that same kind of symmetry argument that we used for our 3 pi over 4 or 135-degree angle here, but we have to be very careful in how we are setting things up. Make sure we are flipping our angle correctly corresponding to that initial angle. And so remember, this is our 60-degree angle here that got us to this point, or this arc length that got us to this point. So when we reflect our reference triangle, or however you want to view this reflection, across the y-axis, what's going to happen as we measure our 60-degree angle is this is not going to be our 60-degree angle here. That might be easy to see because everything is drawn relatively to scale, but that's not always going to be the case. So we have to be very careful in how we are using our angle or arc length argument to get to this endpoint on our unit circle. So we know that this other orange angle here is 60 degrees, but that's going to be 60 degrees when measured starting from the negative x-axis. Okay, so we can also think of that as kind of anti-rotating 60 degrees or rotating 60 degrees clockwise. But we're always thinking about measuring our angles or arc lengths starting on the positive x-axis. So how do we end up at this angle? Well, one way to do it, and you might see this already, this is just one way I see it, is we rotate 180 degrees to get halfway around our circle or through our rotation. Then we have to go backwards this anti-angle of 60 degrees. So it's going to be 180 minus 60, but 180 minus 60 is 120. So now we know this new point on our unit circle, negative 1/2 square root of 3 over 2, corresponds to the angle of 120 degrees. And if we convert 120 degrees to radians, we're going to find that that is 2 pi over 3 radians. So next up, we need to find the angles and arc lengths corresponding to this point, negative root 3 over 2 for x and 1/2 for y. Well, we know this came from the reflection of the point, positive square root of 3 over 2, 1/2 in the first quadrant. That corresponds to the angle of 30 degrees here. And so if we want to find the angle that corresponds to this point, we know that this is a 30-degree angle. This half rotation is a 180-degree angle. So 180 minus 30 gives us 150 degrees. Or if we convert that to radians, that'll be 5 pi over 6 radians. All right, so we've pretty much filled out the second quadrant, right? Maybe we can end with this point on the negative x-axis, right? We can think of that as a reflection of this point across the x-axis. All these arguments are still going to apply, or we can just kind of think of it as, well, what's that left point on our unit circle? That circle of radius 1 centered at the origin. It's got to be negative 1, 0. This point also corresponds to half the arc length to get around our unit circle. The entire circumference of the unit circle is 2 pi. Remember, the circumference is 2 pi times the radius, but r is equal to 1. So half of our radius, or half of our arc length, or 1/2 of rotation, is pi radians. And that, of course, is the same as 180 degrees. All right, so we used our points in the first quadrant and this reflection across the y-axis to help us find points in the second quadrant. Now we can use our points in the second quadrant, reflect them across the x-axis to find points in the third quadrant, and then we're going to find points in the fourth quadrant, basically doing the exact same thing. There we have a choice of reflecting these points across the y-axis or those points from our first quadrant across the x-axis. All right, so if we reflect this point, negative root 3 over 2, 1/2 across the x-axis, well, any reflection across the x-axis is going to keep the x value the same. So it'll still be negative square root of 3 over 2. The only thing that changes is that vertical distance to get to your point gets negated or flipped. So that'll be a negative 1/2 instead of a positive 1/2. All right, so how would we get to this point, negative root 3 over 2, negative 1/2, if we were starting at our initial position along the positive x-axis? Well, we'd have to do a half rotation of a full 180 degrees plus this little extra rotation amount. This little extra angle we know is 30 degrees from our previous argument, and this angle to get to where we want to be corresponding to our new point is going to be that half rotation of 180 degrees plus that special little angle here of 30 degrees, which of course came from that first reflection of our 30-degree angle. So the angle corresponding to this end or terminal point on our unit circle is 210 degrees, or if we convert that to radians, that's 7 pi over 6. All right, so if we do that same type of vertical reflection across the x-axis for those other 2 points in our second quadrant, we're going to find coordinates of negative root 2 over 2, negative root 2 over 2, after reflecting our blue point up here. And for this green point that was corresponding to the angle of 120 degrees or 2 pi over 3, the reflection of that point across our x-axis is going to give us the point negative 1/2, negative root 3 over 2. All right, and so now we have to figure out what are the angles or arc lengths that get us to these endpoints on our unit circle. I think the blue one is a bit easier to do using pretty much any symmetry argument, just because it's that nice clean angle of 3 pi over 4, or a multiple of 45 degrees, I should say. So how do we get to this blue point down here? From our starting position, we have to travel 45, 90, 135, 180, plus another 45 degrees. And so that'll be 225 degrees to get to this point on our unit circle, corresponding to negative square root of 2 over 2 for both x and y. And in radians, that's going to be 5 pi over 4. All right, so now there's lots of different arguments we can make to find the arc length or angle that corresponds to this point near the bottom of our third quadrant. and it just kind of depends on which way you see it. That's the argument that you want to make. So what we really need to do is identify what is this part of this arc length or angle, or what is this part of our arc length or angle. And we're going to find that out using that point that we reflected to get down here. And so if we go back to our point that got us down here, right, that point was -1/2 square root of 3 over 2. From our starting position to get to this point, we have to travel an angle of 120 degrees or 2 pi over 3 radians. And so this half rotation is 180. So that means this part of our rotation or angle here is going to be a total of 60 degrees, and this part here will be a total of 30 degrees, right? Because that quarter rotation has to be 90 degrees. And so now we know is that through symmetry, this little angle down here is the same as this little angle up here. But we just said that that angle had to be 30 degrees. So we can think of this as a 30-degree angle, but we're not measuring our angle from the negative y-axis. We want to measure our angle from the positive x-axis. So we have to do almost 3/4 of a full rotation and then go back 30 degrees. Well, that's going to be a 270-degree rotation, gets us 3/4 through a full rotation, and then back 30 degrees will give us 240 degrees. Right, we also said that this angle here, through similar arguments, was a 60-degree angle. That means that through symmetry, this angle arc would also have to be 60 degrees. Well, that's 180 plus 60 degrees. That gets us to 240. And that's what I meant by it kind of depends on which angle you see and want to work with to figure out that angle corresponding to our new point. Degrees are cool, but we're going to see that radians are even cooler. So now we need to convert 240 degrees into radians, and that's going to give us 4 pi over 3 radians. All right, so we have 12 of our 16 key points on the unit circle filled out. We have 4 left for the bottom of the unit circle and filling in the 4th quadrant. I'm going to go ahead and really speed through those ones because it's all just the same kind of reflections and arc length or angle arguments that we've been making so far. So at the bottom of our unit circle, we have the point 0, -1. That's going to correspond to an angle of 270 degrees or 3 pi over 2 radians. All right, and so those last 3 points on our unit circle to finish off that 4th quadrant are going to be 1/2 negative square root of 3 over 2 for this point down here, square root of 2 over 2, negative square root of 2 over 2 for this point kind of in the middle of our 4th quadrant. And that last point near the positive x-axis is positive square root of 3 over 2, -1/2. Now, how these points were generated can come from a couple different places. We can think about reflecting these points in the 3rd quadrant across the y-axis. I noticed my scale here got a little wonky, sorry about that. Or we can take our original set of points in the 1st quadrant and reflect them across the x-axis. Either way we do it, we're going to land at these ending points on our unit circle. So what is the angle corresponding to our blue point down here with positive root 2 over 2 and negative root 2 over 2 for its x and y coordinates? Well, we know it kind of came from this angle up here corresponding to pi over 4. So this will be a pi over 4 angle, or this will be a pi over 4 angle. The entire trip around the unit circle is 2 pi radians. You can think of that as an angle or an arc length. So we have to go all the way around 2 pi and then back pi over 4. And that'll leave us at 7 pi over 4. Or you can think about going 3 pi over 2 around our unit circle and then add on an additional pi over 4. But 3 pi over 2 plus pi over 4 is also going to get us 7 pi over 4. And if we convert that to our angle in degrees, I believe it should be 315 degrees for that angle. All right, and so those last 2 points correspond to angles of 11 pi over 6 and 5 pi over 3, or in degrees, 330 degrees and 300 degrees, respectively. We need to memorize these 16 key points on our unit circle, because when we use our trig functions from here on out, these angles are going to show up all the time. And so by knowing these 16 key points on our unit circle, we'll be able to find the exact value of our trig functions for these special angles.